Right, so we represent these molecules and compounds through chemical formulas. So let's take a quick look at how we're going to write out these chemical formulas. So an example of this is water. Most people know that water is H2O, right? And the 2 means that there's 2 hydrogens and then 1 oxygen, right? That's what the formula means. If we take a look at another compound, ammonia, that's NH3, right? That means that we have 1 nitrogen and 3 hydrogens, right? Overall, pretty obvious, right? So for another example, right, carbon dioxide, the 2 means that we have 2 oxygens. Molecules can get a lot bigger than this. So for example, sucrose, which is essentially just sugar, is C12H22O11, right? So we can have a lot more stuff than that. In general, we have some kind of baseline rules of how we write formulas to make it a little bit more standardized. So when you have ionic compounds or metals and nonmetals together, we generally put the metal first. So for example, sodium chloride is NaCl because sodium is the metal. So it goes first. It is not ClNa because that would be putting the metal second. When you have hydrogen, hydrogen generally goes first. The exception here is with carbon. If there's a carbon, then the carbon gets to go first. So for example, water we write out as H2O because the hydrogen goes first. Sulfuric acid is H2SO4, the hydrogen goes first. And then with the molecule CH4, this is methane. When we have a carbon involved, it gets to go first. When you have a bunch of nonmetals together, the less electronegative atom goes first. So for example, between SO3 and O3S, if you take a look at your periodic table, you'll find that the oxygen is more electronegative. So the sulfur is the less electronegative atom. And so it's going to go first. The correct formula here would be SO3. Overall, this isn't too big of a deal, and it's just something that you're going to get with practice.